Okay, so this is going to be a repeat of the AC Flatness test on the AFG31052 arbitrary function generator from Tektronix. I previously tested this with this little fellow down here in combination with the Fluke. The Fluke will go up to 300 kilohertz. This little device will go from 1 megahertz to 8 gigahertz, but I couldn't get the proper reading between 1 to 5 megahertz. So I found another unit off of eBay. This is the AE20401 up here, and this should go from DC up to 500 megahertz. Now I have a bit of an issue calibrating this. I can calibrate it down at the bottom end because this will go up to 50 megahertz, but this requires calibration frequencies beyond that, which I haven't been able to perform. So it's not a fully calibrated unit, but I would expect it to operate down at the lower frequencies correctly. So at the moment I've got the function generator set up. Both channels are on 1 kilohertz, 4 dBm, and you can see my Fluke, it's on channel 2 and he's reading 3.96 dBm, and I'm not sure how well you can see the 20401. Hopefully you can. It's actually reading somewhere between minus 13.9 there, 14.5, 14.4, so it's out quite badly. What we'll just do is I'll take the frequency up to 100 kilohertz and we'll see what happens. So you see my Fluke is 3.92 and 4.4 now on the frequency counter. Let's go 300 kilohertz. So 4.2, 3.95, that's now the maximum of the Fluke. I can't go any higher than that, but we are at 4.2 dB, which is fairly accurate. Let's just take them down to see where it starts to drop off. Okay, so 60 kilohertz there. Yeah, it's become unstable at 60 kilohertz. 70 were quite stable. So yeah, to me this isn't DC to 500 megahertz. It's not quite right in that respect, but at these high frequencies it seems to be fine. So I'll just disconnect the Fluke because it's not going to like going up to the higher frequencies, and I'll replace that with a lead to the small little unit down here. Okay, so hopefully you can see everything. I've got the AFG31052 set up at 1 megahertz output. Channel 1 is going to track channel 2. Channel 1 is connected to our AE20401, currently reading 4.1 dBm, and channel 2 is connected to our little unit down here, which is currently reading 1 dBm. So you can see the difference between the two. Let's take it up, we'll go up to 2 megahertz. That stays on 4.1 now. Unfortunately I have to change this setting every time. There we go, 2 megahertz. So that's 2.5 dBm against 4.1, up to 3. Now we're reading 3.9 to 4 dBm, which is a lot closer. 4.1 dBm on the other meter to 4 megahertz. And also you notice, whilst this is a nice little, let me drop back down to 3.3 now, little meter, it's a pain having to keep readjusting the setting on there, which I don't have to do on the AE20401, so that's one advantage of it. But you're still reading 4.1 at 4 megahertz, got to 5, 3.6 there. We'll take it up to 10 megs, 10 megs there, and so we've got 3.9 here. 3.9, got 4 on the other meter to 25 megahertz. 25 megahertz, we're reading about the same now, 3.9 and 4 and the final one will be 50 megahertz. So interesting, this has now started to drop off at 50 megahertz, whereas the other one has stayed more consistent. That could be to do with the calibration. I've been unable to perform as good as I'd have liked to on this. Okay, so this little meter does appear to be a bit of an improvement over this other one. I'll have to see if I can get it calibrated properly to try and stop the reading dropping off at the higher frequencies, but also I'm not finding this meeting the specification. It's certainly not DC to 500 megahertz. It was dropping off at around about 70 kilohertz. Never mind, interesting little exercise. Thanks for watching, hope you enjoyed it, and I'll see you again in the next video.